Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationcity.com. In this film, we are talking about the parametric linear programming focused on systematic change of C sub j. Let's move on.
Now let's go to the great general case, which is parametric linear programming. During the sensitive analysis, we study the discrete impact of the model parameters on the final solution. However, when we need to examine the effect of continuous change in the parameters across the various possible values, we utilize the parametric linear programming. The systematic change of the parameter Cj is the first part. Let's consider the given objective function. Here, this is the objective function. In the parametric programming, we replace the objective function with the following function. Here, aj represents the constant data that determine the rate of change in the objective function coefficient. We increase the value of theta from 0 to demonstrate the effectiveness of the linear programming model as theta varies. Let's examine the following example. Let's consider a1 is equal to 2 and a2 is equal to minus 1. So the objective function can be written as follows. Starting with the final simplex table with theta is equal to 0, the objective function becomes here. We incorporate the change in the objective function on the left side, resulting here. So we change the objective function by this part. Since x1 and x2 are a basic variable appearing in equation 2 and 3, their coefficient in the objective function should be 0. This can be achieved by adding the equation 2 and 3 to objective function as elementary operation as we discussed in the earlier course. That's yield to here. Based on the stopping condition of the primal simplex method, if the coefficient of the non-basic variable remain non-negative, here the basic feasible solution is considered optimized. Therefore, in our case, this condition holds true. Okay, if theta hold this condition, here we have the optimal solution with the basic variable x2 and x3. Hence, if theta become greater than 9/7, we select x4 as an incoming basic variable because it has a negative coefficient in the objective function. And a new optimal solution obtained using the prime simplex methods. The new simplex table with the x entering base and x3 leaving the base based on the ratio test is as follows. So if theta become greater than 5, we choose x5 as an incoming basic variable. And a new optimal solution is obtained using the simplex method. The updated simplex table with the x entering as a base and x2 leaving the base determined by the ratio test is as follows. As seen here, this is here, as we increase the theta is greater than 5, we have this table. As seen in this table, when x5 exceeds 5, all 0 rows remain non-negative. So we can see that if theta is greater than 0, the coefficient of the objective function in row 0 is greater than 0. This implies that the value of the theta can be increased indefinitely without affecting the basic variable. The overall result of this procedure for various theta are summarized in this table. So it depends on the value of the theta, you can pick one of these 3 tables. Also, the value of the objective function as a function of theta is depicted here. So you can see that if theta is equal to 9/7, you have the minimum objective function. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by form by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.